Hey everyone, welcome back to TechTrouble Solved. Today we are going to solve a very popular array problem, remove duplicates from a sorted array. This is LeetCode Problem 26 and we will solve it step by step using a clean two-pointer approach without using any extra memory. Let's dive in. Let's first understand what the problem is asking. We are given a sorted array and our task is to remove duplicate values in place. That means we are not allowed to create a new array. At the end, we simply return how many unique elements exist. Anything after that count in the array does not matter. So, the real challenge here is doing this efficiently using the same array without creating a new array. Now here is a very important question. Why does the array need to be sorted in the first place? When the array is sorted, all duplicate values sit right next to each other. Because of this, we don't have to search the entire array for duplicates. We only compare neighboring elements, and this single property is what makes the two-pointer technique possible. So let's talk about the main idea. We will use two pointers. Pointer I keeps track of the last unique element we have placed. Pointer j scans the array to find new values. Whenever j finds something different from what I is pointing to, we know we have found a new unique number. Let's start by initializing our both pointers I and j. We always start by placing I at index 0 because the first element in a sorted array is always unique. Pointer j starts from the next position and begins scanning the array. Next step is we compare and copy. We compare the values at I and j. If both values are the same, that means we have found a duplicate. In this case, we will just move the j pointer forward to scan the next elements in the array. Whenever we find an element where j points to a value that is different from I, we have found a new unique element. In that case, we will move I one step forward and copy the value from j into position I and move j pointer forward. This way, all unique values slowly build up at the front of the array. Now let's see this in action by using a dry run. In step 1, pointer I is at index 0, pointing to the first element, which is 1. We always treat the first element as unique as we discussed. Pointer j starts at index 1, pointing to the next element. From here, j will scan the array to find new values. Now we compare the values at I and j. Num I is 1 and num j is also 1. Since both values are the same, this means we have found a duplicate. When we see a duplicate, we don't move I, we only move j forward. So now j moves one step forward and j is now at index 2, pointing to the value 2. Pointer I is still at index 0, pointing at 1, and j is now at index 2, pointing to the value 2. Now we compare again. This time num I is 1 and num j is 2. These values are different, which means we have found a new unique number. When this happens, we move I forward by one position. So I moves from index 0 to index 1 and we copy the value from j into this position. Now the array starts building its unique prefix. After copying, pointer I now points to the value 2. Pointer j moves forward to continue scanning the array. So now j is at index 3, pointing to the value 3. Now I is at index 1 and j is at index 3. We compare nums I, which is 2, with nums j, which is 3. They are different, so this is another new unique value. We move I forward from index 1 to index 2 and copy the value 3 into that position. Now j moves to the next index. Now I is at index 2 and j is at index 4. J points to the value 3 again. This time nums I and nums j are both 3. So this is a duplicate. We don't move I. We simply move j forward. At this point, j has reached the end of the array. That means our scan is complete. All unique values have been placed at the front of the array. The first part of the array now contains only unique elements 1, 2 and 3. Pointer I stopped at index 2. So the number of unique element is I plus 1, which is 3. Anything after this position does not matter. Notice something important here. J scanned the entire array, but I moved only when a new value appeared. That is the heart of the two-pointer technique. Let's clearly understand how these pointers move. Pointer J always scans the entire array from left to right. Pointer I moves only when a new unique value is found. That's why j moves much more frequently than I. So we can see the table here where I, unique builder, starts at 0, moves only when a new element is found and stops at last unique element index. And j scanner start at 1, moves always, that is in every step, and stops at end of the array, that is the last index. Now let's look at the different edge cases. Let's start with the first edge case. What if the array is empty? In this case there are no elements at all, so the answer is simply 0. Next, consider an array with just one element. That single element is already unique, so we return 1 and no pointer movement is needed. Now imagine all elements in the array are the same. Here pointer j keeps finding duplicates, so I never moves. Only the first element is kept and the answer is 1. The next edge case, the array starts with unique values, but duplicates appear only at the end. The algorithm still works smoothly. I stops at the last unique value and j simply skips the remaining duplicates. Sometimes the array is very large but contains only a few unique elements. Even here j scans everything once and I moves only when needed. That's why the solution stays efficient. This last edge case is very important. The solution works only if the array is sorted. If the array is not sorted, duplicates will not be next to each other and the logic will fail. Here is the pseudocode version of the logic we just saw. We initialize I, loop with j and compare values and copy only when we find a new unique element. This keeps the solution simple and efficient. If you look closely, each line of this pseudocode directly matches the steps we animated earlier. Nothing extra is happening. We are just carefully controlling when each pointer moves. Now that the logic is clear, let's switch to LeetCode, write this in Python and submit our solution. Now let's look at the problem. Given an integer array nums sorted in non-decreasing order, remove the duplicates in place such that each unique element appears only once. The relative order of the elements should be kept the same. So here there are few examples where nums equal to 1, 1, 2. So output is 2 because there are only two unique elements 1 and 2. So here it does not matter what you leave beyond the returned key. Hence there are underscores. There is another example which is 0 0 1 1 1 2 2 3 3 4, and there are 5 unique elements, so 0 1 2 3 4 and the rest we left at underscore. Now the constraints. Here num's length, that means the array length, should be greater than equal to 1 and less than equal to 3 into 10 to the power 4. So basically this means the array will have at least one element and at most 30,000 elements. This tells us we need an efficient solution, ideally one that runs in linear time. So O of n and O n log n is still possible, but O n square complexity is not allowed because this will be too slow for 30,000 elements. That's why two-pointer O n solution is perfect here. And nested loops, that means O n square or beyond, would time out. So the next constraint is the array can contain negative numbers, 0 and positive numbers. The value range does not really affect our logic here because we are comparing values, not indexing by them. So the constraints tell us two things. The array can be fairly large and the values can be negative. So we need an efficient comparison-based approach. Because the array size can go up to 30,000, as O of n two-pointer solution is both safe and optimal. And nums is sorted in non-decreasing order as we discussed. If it is not in non-decreasing order, the solution will fail. Now let's jump to the code. So as per our logic, we will first initialize I as 0 and j will start from 1 till end of the array. So we will check for the equality between nums I and nums j. If both are not equal, as per our logic, we move I pointer forward, copy the value from nums j to nums I and move j pointer forward. Let's write it. Now we no need to increment j since j will be incrementing when we loop over the entire array. Also we no need to check if nums j equal to nums I, since what we do there, we just move the j pointer forward when both are equal, and we will be moving j pointer forward when we loop through the array. So we can just now return I plus 1 because that will be the number of unique elements. Let's run it. Let's submit. It's submitted successfully. Now that we have implemented and submitted the solution, let's quickly understand how efficient this approach is. The time complexity is O of n because we scan the array once. The space complexity is O of 1 because we don't use any extra memory. The key idea to remember is sorted arrays makes duplicates adjacent and two-pointer help us build the unique prefix efficiently. That's it for this problem. If this explanation helped you, please like, share and subscribe to TechTrouble Solved. Thanks for watching and I will see you in the next video.